Alright, welcome back to Master Space video tutorials, and in this video we are going to look at one interesting topic, and this calls trigonometry that I'm sure what most of you are waiting for. But please don't forget to go back to watch the video under curve fitting, because they are all what is going to build your concept to be able to grab the ones that we are going to do here. So the curve fitting will determine the modeling with the trigonometric functions. Alright, so and again we are going to look at sinusoidal functions. And by the end of the lesson, you will be able to determine the modeling with the trigonometric functions. Very good. Now, when we say a sinusoidal function, what does it even mean? Don't forget here we are going to relate more in our real life. And if you are relating something to your, if you are relating something to our real life, you don't know what that thing is even is. In fact, it becomes something else. So you'll be hearing a word like Ferris, Ferris wheel, Ferris wheel, and others. So I would like to show you a video, alright, and after that you come back to watch to solve more questions.
Focusing on a single point on the wheel, we see uniform circular motion. A second point, which only tracks the vertical, shows the sinusoid motion. The sinusoid motion is fast in the middle, while slow at the top and bottom. If we consider our sinusoid in time, we end up with a graph like this, with positive peaks in, strangely enough, the positive side, and troughs in the negative. And of course, the zero crossing when the amplitude of the wave is zero. These graphs could also be in distance as well, but we'll only be interested in time for this video. Further, our sinusoid can be completely defined by three properties: the amplitude, which is the vertical measure of the wave; frequency, in this case cycles per second or the period; and the phase, which is defined as a shift at zero time. Coming back to our spinning wheel, we see that one complete rotation creates one cycle of the sinusoid. In this case, every second cycle is shown in blue. The highlights in yellow reveal one complete cycle with a positive peak and a negative trough. The wave is symmetrical about the axis. Let us consider the phase of a wave. In this case, the wave is frozen at time zero. The phase angle is zero at time zero. However, if we apply a 45-degree phase lag, we see that the wave is effectively time-shifted, specifically delayed by 1/8 of its original period. If, however, we apply a 45-degree phase lead, we see that the wave is positively time-shifted by 1/8 of its original period. Here I have juxtaposed the phase lag on top with the phase lead on the bottom, so you can observe how different phase shiftings affect a single frequency wave. Looking at another situation, we apply a 90-degree phase lag, producing a quarter period time delay. This is essentially equal to a phase lead of 270 degrees with 3/4 period time shift. Next, we apply a 180-degree phase lag, which results in a corresponding half-period time delay. This is equal to applying a 180-degree phase lead for a half-period time shift. As you can see, the original wave is completely inverted. Now a 270-degree phase lag has a corresponding 3/4 period time delay, or a 90-degree phase lead with a quarter period time shift. And finally, a 360-degree phase lag is equal to a 360-degree phase lead, each with a time shift of 1 period. As you can see, we cannot distinguish between the original zero phase and the phase-shifted waveforms. This also shows that 360-degree phase change, or 1 full cycle,
Alright, so let's go and look at our first example. Alright, so I would like to project the first example for you so that I will come back for us to watch the video. Alright, so let's look at our first question. A Ferris wheel with radius of 20 meters. So that means that, watch, if we have this to be, let's say this is our Ferris wheel. Alright, so very good. Now, if this is our Ferris wheel, let me sketch this one first. Okay. So let's take this to be our Ferris wheel. Alright, so a Ferris wheel with radius of 20 meters. Radius of 20 meters. That means that you know that this one will be the diameter. So 20 meters means that from here to here, that is 20 meters. Very good. 20 meters. That is the radius. And you know that is the same as that for this. This is also going to be 20 meters. Let's continue. Rotate once every 40 seconds. Rotate once every 40 seconds. That means that it goes one revolution every 40 seconds. It goes one revolution every 40 seconds. So that means that we can get that for, and the revolution is the one that is going to be on the Earth axis. Alright, so we are going to get this. We are going to get this. This one is going to be hours per minute. Because we are dealing with time and minutes here. Alright. Time and meters here. Very good. Then what will be on this side is going to be time per second. Very good. But before you bring that, let's continue to read and see. Okay. So passengers get on at a point B. Passengers get on at a point B, which is 1 meter. Which is 1 meter. So when this was rotating, I hope you are watching. When this was rotating, passengers get on at 1 meter. So if we have here to be 0, this one is going to be 1, and that is where the passengers get on. Alright, and where the passengers get on, let's continue. B, which is 1 meter above the ground. Good. And that is what? 1 meter above the what? Ground. Passengers get on at a point B, which is 1 meter above the ground. So if this is the ground, that's why before you approach modeling question, don't just start by sketching your X axis and your Y axis and start drawing your Ferris wheel in any way. You have to take your time, read the question, sketch that for the Ferris wheel, locate the radius, and now everything will come by itself. So you can see that person that get on at point B, which and that point B, we are saying that it says which is 1 meter above the ground. So this, if this is the point B, that is 1 meter above the ground. So this will be the ground, and the ground will start from 0, right? So that is going to be the ground, all right? And don't forget that it goes how many revolutions? That is 40 revolutions. That is 40 seconds, all right? Very good. So that is going to be that. So for 40, so that means that the time period is 40 seconds. All right, the time period is 40 seconds. Now, for us to determine what will be here, we need to multiply 1/4 by 40, and that is going to give us 10. All right, so we start at 0, then we start adding 10. So here will be 10, here will be 20, here will be 30, here will be 40, and that will be at the end of the what? The period, that time per second. Very good. So let's continue. That is where we are. And now, when the passenger gets on at the point of B, it will begin to what? To rotate. So to start from here. All right, I'm coming. To start from here, know that your Ferris wheel will start from here. All right, so that is what you have to know for that place. Let's continue. Suppose you get on at B and the wheel starts to rotate ahead. So when you get on at B, then the wheel starts to rotate. All right, then the wheel starts to rotate. So when it starts to rotate, you go like this, that. Now, let me show something here. This one is too close to this. Let's level it for. Okay, so let me use the thing here. 20, 30, 40. Very good. Please, this is not asymptotes. Alright, very good. So it will start to rotate. So that will move from this to this. So there's going to be a point here. Or you can see that there's going to be a point here. Then it gets to, now if from here to here is 1, from here to here is 20. Alright, that means that here will be 21. Alright, and from 21, what is going to be here? From here to here is 1, from here to here is 20, 21. So from here to here is 20, so 20 plus 21, that is going to be 41. So this place is also going to be 41. So it's going to have a cut here. Alright, so one will be here, the other will be here. Then to come back, because it's going for one revolution. So the next one too is going to be here. And the next one too is going to be here. Alright, that is how we do the graph. Very good. Very good. So that is how the graph will look like. Because 1 is 1 meters above the ground, so here is 1. The radius is 20. So only this gives what? 40. So here will be 41. So there's going to be a cut at where the time is 10. That is 21, and 20, 20 will give us 41 here. 30 will give us 21 here. Then 40 will give us 1 here. Alright, so that is going to be for that. And that is 1 revolution. So now watch. The question says that write an equation which express your height as a function of time. That means that we are going to represent the height of the person, as a function of time. Alright. So let's go for this important thing. Now we need to know the maximum height. And you can see that the maximum height, we'll come back to that later. The maximum will be, that is going to be 40. Sorry, for 41 is going to be the maximum. Then the minimum also will be here. This is going to be the minimum. Alright, the minimum. Then this is going to be the mean. This is going to be the mean. This is going to be the mean. So let's now move on to go and find the equation. And the equation, we need to go for the period. Alright? And we know that the time period, but I would like to explain this part. And we know that the time period is 40 seconds. Okay? So B will be equal to 2 pi over 40. And that's going to be pi over 20. So that is going to be for the B. Alright. Then, you know that in general, the equation will be in the form y is equal to capital A F into bracket BS minus C plus D. Alright, now here the F here is used because it can be either sine or what? Cosine. And that is a sinusoidal function. It can be whether sine or cosine. Not even tan. It can be whether sine or cosine. So straightforward. We need to go for the A. The A is the amp now. The B is known now. So we need to go for the A. And that is the amplitude. So we go for the amplitude. The amplitude, alright? And you know that the amplitude is maxi minus the mini over 2, alright? That is the maxi minus the mini over 2. And we know that the maximum value is 41. And the minimum value is 1 over 2. That will be 40 over 2, which is 20. So that means that the amplitude here, is going to give us 20. The amplitude here is going to give us 20. Please, don't confuse yourself. In the moment you get see 41, you say, oh, that's going to be the amplitude. No, that's not that. That's how we calculate for the amplitude. Alright. Then let's go for the average. And the average is the same as the vertical shift, and that is the D. So we go for the average. Alright? And that is the capital D. Don't forget that even if you don't know that this is the mean, now watch. The D is equal to the maximum plus the minimum over 2. So this is going to give us 41 plus 1 over 2. 41 plus 1 over 2, and that is going to give us 21. Therefore, the d is equal to 21. Then what's the next thing to go again? What is left now? Don't worry about the f, whether it's going to be sine or cosine. I will let you later. Oh, we are left with one more. That is a c. So, what do you think the c is going to be? Alright. Now, you know that in full revolution, we are going to get 40 seconds. Alright, so watch. Now, note that the c, okay, this is the general term, so let me make it plus or minus. Note that the c is the horizontal shift, whether it's shifting to the left or to the right. Alright, so it's whether it's shifting to the left or to the right. There is one more thing to take note that if it's a sine function, it will start at, don't forget, always a sine function starts at origin. The sine function starts at origin. So if this to be a sine function, it will start at the what? The origin. Alright, that means that it will start here, which is the origin, then it goes like that. Alright, so this part that is going to come off will now continue on this side. Alright, and that's going to give you that for a sine function. So the c depends whether you are going by a sine function or a cosine function. Alright, so that is that. And if it will be a cosine function, it will start at 20. If it will be a cosine function, it will start at 20. So if it's a cosine, you know that a cosine, one revolution is like this, or this. Whether this or this, alright, that is one revolution. So if it's a cosine, it will start from 20, so that you extend this side to the other end, alright, and that's going to be a cosine. But we are saying that sine will be something like this or something like this, alright, whether here is concave down or it is concave up. Very good. So for it to be a sine function, it will start from 10, and for it to be a cosine function, it will start from 20. Alright. So the equation depends on you, whether you want to use the sine or the cos. Alright. But since this is our first question, I would like to show you how to get or how to write it in the two form, whether sine or cosine, I hope I'll take my time to explain to you more. All right, very good. So let's go and write the equation. But I don't want to do it. That's why I'm moving around like that. All right. Okay, I think I have to clean it. Okay, let's clean this part. Let's clear off this part. Very good. All right, so for the equations, 1, let's choose it to be a sine function. Let's assume if it's a sine function. So 1, you start with, now since we want to determine the height of the person, let's use h, and it's going to be h in terms of, okay, this one is the general form. I don't want to touch it, let me leave it. Alright, now since we want to determine the height of the person, I would like to use h, and it's in terms of what? Time. Very good. Then you want to use sine, alright? But you have to go for the amplitude. And you want the amplitude to be, what is the amplitude? That is 20. So the A here is the amplitude, which is 20. Now the F here, you want to use sine. So sine. Sine. Then we open the bracket. What is the B? The B is the period, and that is pi of 12 over 20. Pi over 20. Very good. That will be pi over 20. Then we move on to the inside. The inside, we're going to have S. Now here, that's what I was saying, that it depends. Alright. So if you are using the sign, that means that it will start for sign, that means that it will start at 10. So you see, it will shift to the right, alright? It will shift to the right. And when it shifts to the right, you know we don't use plus, but we use minus 10. Minus 10. And you close it. After that, you close it. Plus, you know that the vertical shift. Where is the vertical shift? I've closed that something. You know that the vertical shift. Okay, the vertical shift, we have 21. And that is 21. Very good. So that's how we determine the equation. That is how we determine the equation. Alright. Secondly, you can choose to use a cosine function, but that one, it will shift to the right at 20, at where the time is 20. And when that happens, here the amplitude will come, the cosine will come, the period will come, alright. But with this, it will be S. Now, it's still shifting to the right. It's still shifting to the right. At where T is 20. So you get S minus, because it's shifting to the right. So S minus 20. Then you close it plus 21. So, how will enjoy the class? Very good. So it depends. Okay? The F here can be sine or cosine. But don't forget, if you are writing it in sine, that means that it will shift to 10. And if you are writing it in cos, it will shift to 20 because cos graph is in this way. And if it shift to, and if it shifts at where at where t is 10, you are going to get a sine function, so you will extend it furthermore again. Very good. And if it is cos, you bring the other part to this side. Thank you, and see you for the next video. Sorry. In this same video, we are going to look at the second question. Alright, we are still getting through. Let's look at our second question. I'd like to bring this part so that I will get more space. So we look at our second question that says that a Ferris wheel with radius with 2.5 meters. A Ferris wheel with radius 2.5 meters. Please, always when you're reading the question, don't be in a rush. Just take your time. Okay. So you go and draw your Ferris wheel as I said, it's like a bicycle wheel. So we know that the radius of this Ferris wheel, which is a circle, is 2.5 meters. So that means that alright, so the radius from here to here, that is 2.5 meters. And it will be the same as from here to here. And that is 2.5 meters. Nice. Take your time, okay? And do it. Let's continue. So a Ferris wheel with radius with 2.5 meters makes one revolution. Makes one revolution. That is after every 12 seconds. So we are saying that this makes one revolution after every 12 seconds. Alright. So that means that if it starts from here, it moves till it comes to the original place. And that is making one revolution. And we are saying that it makes one revolution every 12 seconds. Alright? Very good. So you know that the 12 seconds is going to be the period. So just note that down because that's what's going to be on the S-axis. But please take your time. Don't just be in a rush. Oh, the moment you hear 12 seconds, then you quickly come and drop. Then you start. You go and multiply by 1/4, then you start doing what you don't understand. Please take your time. Don't be doing what you don't understand because it doesn't mean that the S-axis will attach with the circle. No. Read to understand what the question is saying before. Alright, so finish reading the question. Let's continue. It is 2 meters above. So we are saying that the Ferris wheel is 2 meters above the ground. So there is no way that your S-axis will be here. No, that would be wrong. Because we are saying that this Ferris wheel is above the ground. And this is the ground. The S-axis is representing the ground here. And it is above the ground 2 meters. 2 meters. Very good. So it will not be here. But will rather be here. Alright. So now let's take from here to here to be 2 meters. I hope you are getting the concept. Thank you for that. So you draw your line here. Nice one. Nice one. Then you start, you know that it always starts at 0. So you start at 0. But you are saying that the period or it makes 12 seconds after one revolution. So that means that the period or the time period is going to be 12. Alright, that's going to be the time period. That's going to be 12. So you multiply by 1/4. And that is going to give you 3. And that is going to give you 3. So it means that you start at 0, then you begin to add 3. You start at 0, then you begin to add 3. Alright? But make sure that the 3 don't be under the Ferris wheel. It will not be under the Ferris wheel. Alright? So you can get it here. So we have 3. Then 3 plus 3 again, you get 6. 6 plus 3 again, you get 9. Then, till you get to 12, then you stop because that's for after one revolution. Alright, so now when you add 3 to 9, you get the 12. Don't continue again. And show that this is your time per seconds. And this is going to be, alright, even that one, I have to take my time and make sure that I'm done with the paper. Very good. So let's look at that. It is 2 meters above the ground. Okay. 1. Draw a graph that models the height of the Ferris wheel with respect to time. Oh, that is what we have to. That's what we have to do. Very good. So this one is going to be our the height per meters. the height perimeters. Very good. So, as I said in the previous example, this is not an asymptote. This doesn't mean that it is asymptotic at this point. No. This doesn't mean it's an asymptote here. I'm just using that as a level. So the minimum will be here. This is going to be the minimum. Then this is going to be the mean. This is going to be the measure. Alright, very good. So we have the maximum value, the minimum value, and the mean. Alright, so want to come here, and want to come here, and want to be here. We know that this is 0, this is 2. Alright, now watch. Please watch. Take your time. Stop whatever you're doing and watch me. If here is 2 meters above, so from here to here is 2, then from here to here is 2.5. From here to here is 2.5. That is the radius of the Ferris wheel. Alright, nice. So what do you think here will be? If here is 2, from here to here is 2.5, what will be from here to here? So what will be here? Don't forget that will be 2 plus 2.5. That because from here to here is 2, here to here is 2.5. So here will be 2 plus 2.5. And that's going to give you 4.5. 4.5. If your calculator is telling me the right thing, that's going to give you the that's going to give you 4.5 there. Very good. Let me bring the equal to you. And what do you think here will be? So that will be the additional of the 2.5 here. So that's going to be 4.5 plus 2.5. And that's going to be 7. Yeah. That's going to be 7. That's going to be 7. Very good. That's going to be 7. So let's see what is going to happen. So the Ferris wheel is going to start from here, right? So there will be a cut there. I hope you can see that. And for this, it's going to cut here. And for that, it's just simple. It's just simple. Just simple. Very good. And what for this? That's going to be here. Alright, that's going to be here. And this one is going to be here. I hope you can see how we trace the point. It's not difficult. That's how we trace the point. It's not difficult. So that's why it's good to show this. Alright, and it doesn't mean that it's an asymptotic sign. So it starts from here. Oh wow, nice. I love this thing. You see how it is? Very, very, very nice. So now we can get the maximum value. So let's go for it. What will be the maximum value? Because before you identify before you get the right maximum value and the right minimum value, going for the amplitude and the average, which is the same as the vertical height, is going to be very difficult for you. Alright, so let's go for that. Let's go for that. Let me clean this part so that I can do my workings there. So here, the maximum will be 7. The minimum will be what is it? 2. 2. Alright. So quickly let's go for the amplitude. That's going to be maximum plus the minimum over 2. So 7 plus 2 over, is it minus or plus? Let's check what. Because for the maximum and the average, one is plus, one is minus. Okay. Okay, the amplitude is minus. The amplitude is minus. So amplitude is minus over 2. Very good. And in fact, you need to understand it. So that's going to give you 7 minus, that's going to give you 5 over 2. And this is going to give you, that's going to be 2.5. That's going to be 2.5. So 2.5 is going to be the amplitude. And don't forget that the amplitude is always positive. Very good. The amplitude is always positive. Now I'll tell you something, but let's finish getting all these things. Let's go for the average, or the D. That is 7 plus 2 over 2. And this is going to give you 9 over 2. And the D is going to be 4.5. 4.5. Alright. After this, what is left? Period. So we go for the period. That is the B, which is going to be 2 pi over. Now, after one resolution, what we have? 4. Very good. That's what I like. So, this is going to give you pi over 6. Pi over 6. Okay, what is left again? C. And the C depends whether, in fact, I always advise students to take their time for determining what the C is going to be. Because it depends whether you are going to have a shift or not. Alright? Now, at origin, now this graph is at origin, alright? And what you can see here, this is a cosine graph. And for this, you can see that it's at origin. So there will be no shifting here. There will be no shifting here because this is at origin. But if you want to use sine, alright, if you want to use sine, that means that you have to shift to the right at where t is 3. So that means that here you are going to get a horizontal shift, not vertical, a horizontal shift of 3. How you can see that? Very good. So it's whether you are using sine or cos. So let's go for it and see. Let's go for it and see. Very good. Also, it's important for you to note that note it somewhere, okay? If your graph, I don't care whether it is cos or sine, if you have it to be downward like this, if it's open downward, your amplitude, even though the amplitude is always positive, but when you are bringing it to where the equation is, you have to negate it. So here, you need to negate the amplitude. Note it. Very, very, very important. You need to negate the amplitude. But if it's like this, that's going to give a positive amplitude. Alright? What about if it's sine? Now, sine 2 will be like that. Sine 2 will be like this. If it goes like this, determine it here. Alright? You see this side is the same as it's similar to this side, okay? So that means that for this is going to be negative. Alright? This is going to be negative. But if sine go like this, that's going to, this is negative and this is going to be positive. That's how we do it. Right? That's how we do it. So make sure you take note of it. So the graph will start at 0, so there will be no shifting. If you want to use cos, there will be no shifting. Alright. So let's first write the equation for the cos. So one, the equation. Since we want to determine the height, so let's use h in terms of t. So h in terms of t is going to, because we know the amplitude will come here. And the amplitude, as I said, since this one is open downward, here is going to be negative, and the amplitude is what? 2.5 to negative 2.5. Please, always don't forget that. Cos. Now, the graph is already at origin for cos, so no shifting. Alright. Then, if there is no shifting, you know that here is just going to be bx, right? Or I would say bt. Bt, that's the one after origin, bt. Bt. If there is a shift, you see that to be s minus c. Alright. So here we are using time. So it will be t minus c. I hope you are getting what I mean. It will be something like this. Oh. It will be something like this. Okay. Now there is no shifting. So c is 0. And since c is 0, it's going to be bt. Bt. So the b2, we know it to be pi on 6. So pi on 6t. Very good. That's what you're going to get. Then plus the vertical shift of 4.5. And that is that. So that is the first equation that we can derive. That's the first equation that we can derive. Very good. Alright, so that is the first equation that we can derive. In fact, I want you to grab the concept, okay? You know, it's not only what? It's not only this equation that we can get for cos. We can even derive another cos from this graph. We are saying that this curve is at origin, or this graph is at origin. That means that there is no shift. So the c is 0. Very good. Now what? If you bring it to, if you shift it to the right at where t is 3, know that that is going to give you sine. We can choose to shift it to the right at where t is 6, and that will give you cos, because cos is also like this. Cos is also like this. But don't forget that this one will be open upward, and when it's open upward, that is going to give you positive. Very good. I heard you saying it. Or yeah, I heard you saying it. Very good. So if you shift to the right, you can get another cos. In fact, let's write it. H of t will be equal to here. We want to use cos, but we are not going to shift it here, but we are rather shifting it here. Alright? So this part will cut off. And when it cuts off, it has to come and continue on this side. Right? So we are going to get something like this. And that is a cos which is open upward. And when it's open upward, the amplitude will be positive, but no more negative. Very good. So here the amplitude is 2.5. Cos, very good. So that's going to be cos. Now, here since we have shifted it to where t is 6, there is a horizontal shift to the right. Oh, I love it. If there is a horizontal shift to the right, that means that our c here is 6. So we are going to get the b here with a pi over 6. The amplitude, sorry, the period is still the same thing. Then s, sorry, no more s, we are not using s. T minus shifting to the right at 26. And that's going to give us 6. Wow. And that's going to give us what? 6. Alright. Very good. And the next will be the vertical shift. And that is plus 1.5. So the vertical shift don't change, but the amplitude will change. the shifting will change. The amplitude depends whether it is open upward or downward. For downward is negative, for upward is positive. Very good. Alright, so that is that for that. Now, let's see if we can write some for sine also. Let's go for sine. Alright, let's go for sine. So, for cos, we can only get 1 and 2. And for sine also, we can also get. Okay, I'll try to see if I'll get 1 or 2. Let's look at it. Let's look at it. Let's look at it. I would like to bring this back. So this equation is just for cos. Wow. Don't forget, starting from h of t. Oh, for sine. That means that we have to, you see, at origin, this is a graph of cos. So to get it in sine, we have to shift to the right at where t is 3. Will the amplitude change? No. Is it going to be negated? It depends. Because we have already established that when it is like this, right, it's going to be positive. And when it's like this, it's going to be negative. Alright? So, oh, I made a mistake when showing you that for the sign. Please, you will not be telling it here, but rather here. Sorry for that. It's rather here, so make sure you do the preparation for that. So, this one is upward. So, it is similar to the one that we are doing in cos. So, this one is positive and this one will be negative. So, let's look at something. So, when you take it from here, it starts from here, so that would be a sine curve. Alright, that will be sine. The one which is cut off from here will now come and continue with the one here. So it will be a sine curve. Alright, and you see, here is open upward. So we are going to get a positive amplitude, 2.5 sine. And the b is still pi on 6, but there's going to be a shifting to the right at where t is 3, plus a vertical shift of 4.5. Do the same thing. Lastly, that is 4. Yeah, we can get as many as we can. Very good. So when it's here, you will get sine. Here, no, that is cos. Here, yes, that is sine. That is sine. Because that one too will be like this, then it will be like this. Always clear. It will be like this, then it go like that. Very good. So you can see this is when it is shifted to where S T is 9. So backwards. It starts from here, then it opens downward here. So there's going to be a negative amplitude. Sine pi over 6 t minus 9. Or yeah. In fact, if you still face a problem on modeling with trigonometric functions after watching this video, then I don't think where your your issue is going to solve. I don't think where your issue can be solved. Very good. So that is that. Let's look at our third example, and that one too is going to be nice. In fact, we have 2 more examples to do.